You've definitely heard the word blockchain, right? It's everywhere, connected to everything from Bitcoin to the entire future of the internet. But what is it really? Well, today, we're going to cut through all that hype and get right to the heart of how this tech actually works and why it really might change, well, everything. So, let's just start with the absolute basics. Forget all the complicated jargon for a second. At its core, the whole idea is surprisingly simple. And that's it. Seriously, that's the fundamental idea. It really is a chain of blocks with info inside. Think of it like a digital notebook, but instead of pages, you have blocks, and all those blocks are linked together to make a chain. The real secret sauce is in what's inside those blocks, and more importantly, how that chain is locked down so tight.
Now, you might be surprised to hear this, but the idea itself isn't brand new. It was actually dreamed up way back in 1991. Some researchers wanted to timestamp digital documents so you could prove they hadn't been tampered with, kind of like a digital notary. It was a really smart idea, but it mostly just sat on a shelf until 2009. That's when the mysterious Satoshi Nakamoto adapted it to create Bitcoin, and boom, that's when it exploded. And this quote right here gets to the technology's absolute superpower. It's basically unchangeable. The main problem that blockchain solves is creating a digital record that's incredibly hard to mess with. So how on earth does it do that? Answering that question is the key to understanding all of this.
Okay, so to get the whole chain, we first need to understand a single link. Let's zoom right in and take a look at what one of these individual blocks is actually made of.
Turns out, every single block has three essential ingredients. First up, you've got the data. For something like Bitcoin, this is the transaction info, who sent what to whom and how much. Second, there's something called the hash. And third, and this part is absolutely critical, it has the hash of the block that came right before it.
So what in the world is a hash? Honestly, the best way to think about it is like a digital fingerprint. It's a totally unique code that identifies a block and everything inside it. And here's the cool part. If you change anything in that block, even just one tiny little comma, the hash, that digital fingerprint, changes completely. This makes it super easy to spot if someone's been messing around. All right, so we've got the block down. Now let's see how those digital fingerprints are used to build that secure, almost unbreakable chain that gives the technology its name.
This is where the magic really happens. Remember how each block holds the fingerprint of the one before it? Well, that's what chains them together. Block number 3 points to block number 2. Block 2 points to block 1, and it goes all the way back. The very first block, by the way, is called the Genesis block. It's the beginning of everything. And this structure, it creates an incredible security system.
Okay, so this is the million-dollar question, isn't it? If this whole system is so secure, what actually stops a hacker from just jumping in, changing a block, and maybe, I don't know, giving themselves a bunch of money?
And here's the genius of it. This is the chain's built-in defense system. Let's say a hacker messes with block 2. The second they do that, its hash, its fingerprint changes. But hold on. Block 3 is still holding the original fingerprint from block 2. Suddenly, they don't match anymore. That mismatch instantly makes block 3 invalid, and every single block after it becomes invalid too. The chain literally breaks, and the tampering is obvious to the entire network.
Now, you might be thinking, okay, but couldn't a hacker just change a block and then really quickly recalculate all the hashes for the blocks after it to make it look legit again? And you know what? You'd be right. Modern computers are ridiculously fast. So to prevent that, blockchains have a couple more tricks up their sleeve.
The first layer of this extra security is called proof of work. You can think of it as an intentional speed bump. It's a mechanism that basically makes creating new blocks really hard. It forces computers to solve a complex puzzle before a new block can be added, and that whole process takes a lot of time and a lot of energy.
And to put that into perspective, for the Bitcoin blockchain, it takes the entire massive network about 10 minutes to solve that puzzle and add just one new block. So a hacker wouldn't just have to tamper with one block, they'd have to redo that 10 minutes of intense work for every single block that came after it. That becomes practically impossible really fast.
But there's one more massive layer of security, and it has to do with how the whole thing is structured. Blockchains are distributed. See, instead of one company or one server being in charge, like a bank, a blockchain is managed by a peer-to-peer network. Literally anyone can join. And when you join, you get a full, complete copy of the entire blockchain.
So how does this giant decentralized network all stay on the same page? It's through a process we call consensus.
Whenever a new block is created, it gets sent out to everyone on the network. Each person's computer, we call them nodes, checks the block to make sure it's valid. If it all checks out, everyone agrees to add it to their own copy of the chain. This way, any bogus block a hacker tries to introduce just gets rejected by the group.
So, let's just put this all together. For a hacker to actually pull off an attack, they would have to 1. Tamper with a block. 2. Redo the incredibly difficult proof of work for all the blocks that follow. And 3. Do all of that while also taking control of more than half of the entire global network. It is pretty much impossible. And that is what makes this system so secure.
Okay, so a secure, decentralized digital notebook is obviously a brilliant piece of tech. But why should we care about this beyond just creating digital money like Bitcoin? Well, it turns out the potential applications are way, way bigger.
I mean, just think about it. This tech could be used for all sorts of things. Imagine storing medical records that you know can't be secretly changed, or creating a digital notary for contracts that can't be forged. It could even be used to collect taxes or to power smart contracts, which are basically agreements that execute themselves automatically once certain conditions are met, all without needing a middleman.
And that really brings us to the final big idea here. For pretty much all of human history, we've had to rely on big central institutions, like banks or governments, to create trust between us. But blockchain offers a totally different way. So the question I want to leave you with is this. When the technology itself can create trust, what does that change about how we live, how we work, and how we organize our entire world?